Free response 1 is a proof question. So it gives you t minus sine of t over t dt evaluated from 0 to x, and it wants you to basically see if it matches this power series. So let's go through and let's try to prove that. So when I see this left-hand side, I'm going to look for something that I can turn into a power series, because I eventually need to turn something in here into some sort of series representation so that I can, well, get it in terms of a series. So sine of t is the one that stands out to me the most, and it's actually the only term in here that I can turn into a power series. So if I know the Maclaurin series expansion for sine of t, I can go ahead and I can write that down. And that's why it's a good idea to memorize some of these things, because it saves you a lot of time overall. So this becomes negative 1 to the n, t to the 2n plus 1 divided by 2n plus 1 factorial. Now, I go ahead and I subtract off t. I end up getting t minus n equals 0 to infinity, negative 1 to the n, t to the 2n plus 1 divided by 2n plus 1 factorial. Good. So now, I can actually cancel out this t term here by expanding out the first term in this series. And again, the reason I want to do that is because if I look at my series up here, there's no additional terms added or subtracted. So I don't want this term to be here. I would rather get rid of it so that way I can have just a power series by itself. So what I'm going to do is I'm going to rewrite the right-hand side as t minus, I plug in n equals 0, and I actually get t as my value. And then I just have my series now starting at an index of 1 from negative 1 to the n, t to the 2n plus 1 divided by 2n plus 1 factorial. So now I can actually cancel out my t's in this case. Makes it a lot easier. The next step would be to divide by t, because again, I want everything in my integrand before I apply the integration to it. I don't want to miss any terms because that could throw my answer off. So I'm going to divide by t on both sides. And the new expression I end up getting, I'll write over here, t minus sine of t over t is equal to negative n equals 1 to infinity, negative 1 to the n, t to the 2n. Now I have t to the 2n plus 1, but if I divide by t, I can actually bring this up as t to the negative 1. These powers have the same base, so I can add them together. T to the 2n plus 1 minus 1 is just t to the 2n. So I'm going to leave this as t to the 2n. And I have a 2n plus 1 factorial on the bottom. Now what I'm going to also do while I have the chance is I have a negative 1 and I have negative 1 to the n. I can actually combine that and turn that into negative 1 to the n plus 1. I'm just going to do that for the sake of, well, that's in the answer. So I'm not going to leave that negative outside. So now I'm going to integrate both sides from 0 to x. And when I integrate this power series over here, I end up getting n equals 1 to infinity, negative 1 to the n plus 1, t to the 2n plus 1, divided by 2n plus 1 times 2n plus 1 factorial. And that's evaluated from 0 to x. So because we're evaluating it in this case, we don't have to include plus c at the very end. So my last step here, I'm going to go ahead, I'm going to evaluate this from 0 to x and see what I end up with. So 0 to x, t minus sine t divided by t dt is equal to, so I have n equals 1 to infinity, negative 1 to the n plus 1, x to the 2n plus 1 divided by 2n plus 1, 2n plus 1 factorial. Minus the series evaluated at 0, but when I evaluate it at 0, the series is just 0 itself. So I'm not going to include that. And in fact, this should be our final answer. It matches perfectly with what we have up there. So therefore, we have arrived at the correct free response.
The Teaching Center, UF's Learning Resource Center.